My name is Jacob, and I welcome you to the Global Tutorial 2 class. We are looking at the subject mathematics, and we will continue with our series on set theory. We already have 2 videos on set theory where I look at the terms that are used in set. We've considered many terms, but the last term that I will consider in today's class is the term we call Venn diagram. Now, Venn diagram simply means representation of set information in a diagram. Anytime you present information of sets in a diagram form, what we call it is Venn diagram. For instance, if I have a set and it has only one subset, this Venn diagram would show elements that are in the subset A and in the universal set. I can have a case where I have a set having 2 subsets, say A and B. And I can have a case where I have a set having 3 subsets, for instance A, B, and then C. So anytime you present information of sets in a diagram form like this, we call it a Venn diagram. Now, I'm still going to do a video whereby I will shape out some portions like this, and we will use set notation to what? To denote the shaded portion. For instance, if this is shaded, for instance, if this is shaded, we can use set notation to denote the shaded portion. But in today's class, I want us to apply what we have learned so far on the terms that are used in set theory. And I want to use it in solving 3 questions from your past question. Shall we begin? I'll take the number 1 question. And the number 1 question reads, if A, B, and C are subsets of the universal set U, and such that U is 1 to 12, A is such that 0 is less than or equal to X, and X is less than or equal to 7, B equals 4, 6, 8, 10, 12, then C equals 1, where 1 is less than Y and Y is less than 8, and they now told us Y is a prime number, full stop. They now say, draw a Venn diagram to illustrate the information given above. Then they said B, find B union C, and Roman figure 2, they said A intersection B intersection C. I'll repeat the question again. A, B, and C are subsets of the universal set U, such that U equals 0 to 12, full stop. A equals X, such that 0 is less than or equal to X, and X is less than or equal to 7, full stop. B equals 4, 6, 8, 10, 12, full stop. C equals 1, 1 is less than Y, Y is less than 8, where Y is a prime number. The question A, draw a Venn diagram to illustrate the information given above. Question B, find Roman figure 1, B union C, Roman figure 2, A intersection B intersection C. Now, every mathematical problem has a solution. So we're going to look for a mathematical solution to this question. We have universal set 0, 1, 2, 3, 4, up to 12. We have A. They said A is x such that 0 is less than or equal to x and x is less than or equal to 7. So meaning 0 will be included because 0 is less than or equal to x. So you have 1, 2, 3, 4, 5, 6, 7. 7 will be included because x is less than or equal to 7. Then B, that one is already given. They gave us 4, 6, 8, 10, 12. Then C. Now, in C, there is a question there. They said prime number. Now, you should note something, that prime numbers are numbers that are only divisible by itself and 1. What am I saying? Anytime you have a number that only 1 and itself can divide it, that number is a prime number. Numbers that are divisible by 1 and itself, they are called prime number. Please note something. 1 is not a prime number. These numbers must be greater than 1. So you don't consider 1 as a prime number. So prime numbers will be 2, will be 3, will be 5, will be 7, 11, and so on. These are called prime numbers. Numbers that only itself and 1 can divide. We call them the prime numbers. So in this case now, they told us that what? 1 is less than y, and y is less than 8, and y is a prime number. So it means the elements in C will be 2, 3, 5, and we're going to include 7. We can't include 11 because y is less than 8. So this will be the element in C. Now, we have listed out the universal set A, B, C. The first question now says we should present this information in a Venn diagram. Now, for us to draw a Venn diagram for this, you come down there and say universal set. You have A, you have B, then you have C. Now, what are the elements common to A and B? There is 4 here, there is 4 here. There is 6 here, there is 6 here. So you come here, you put 4, you put 6. What are the elements common to A and C? There is 2, there is 3, there is 5. 2, 3, 5. So A and C, you have 2, you have 3, you have 5. What is the element common to B and C? Is there anyone? No. Okay, so there is no element common to B and C. Is there any element common to the 3 of them? No. No element common to the 3 of them. So if you go back to A, the elements in A are 0, 1, 2, 3, 4, 5, 6, 7. Now we have represented 2, we have represented 3, we have represented 5, we have represented 4, we have represented 6. So what is left is 0, 1, and 7. Then for B, we have represented 4 and 6. So what is left is 8, 10, and then 12. Then for C, we have represented, okay, there is 7. So here you're going to have 7 also. 7. Because 7 is here and 7 is also here. Sorry for that, I missed that out. So we have represented 2, 3, 5, 7 for C. So there won't be any elements here. But here there will be 0 and 1. So let's go back to the universal set. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see if all have been represented. 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have 9. 10, we have 11. So it means 9 and 11, they are not in A, not in B, not in C, but they are still part of the universal set. So this information now has been presented on a Venn diagram. This is the presentation of everything here on a Venn diagram. But that is not the end of the question. Another question says we should find B union C. So you have B union C. Now, I told you that if you're looking for union, the term union, it means you will list the elements in B and C, but you will not repeat any of the elements. So B union C will be 2, 3, 4, 5, 6, 7, 8, 10, and then 12. So this is B union C. You list the elements in B and the elements in C. You will not repeat any of them. And then the last question says we should find A intersection B intersection C. Now, intersection means elements that are common. Now, we have seen that between the subsets, among the subsets A, B, and C, there are no elements common. It means this should be a what? An empty set. And anytime the intersection of sets is an empty set, it means the set is a what? Is a disjoint set, like we have discussed in our class. So these are solved number 1 question successfully. We list out the elements of universal sets A, B, and C. Then we presented it on a Venn diagram, and we are able to discover B union C, then the intersection of A, B, and C. This is the solution to the first question. We are yet going to take another question. And I will dictate the question. If universal sets 1 to 20, okay, if universal set is the set of 1 to 20, and A, B, and C are subsets of the universal set, such that A multiple of 5, B multiples of 4, C multiples of 3, full stop. List the elements of A, B, and C. That's the first question. Then B part of the question. Find A intersection B. Roman figure 2. A intersection C. Roman figure 3. B union C. I'll repeat the question again. If universal set is the set of 1 to 20, and A, B, and C are subsets of the universal set, such that A equals multiples of 5, B equals multiples of 4, C equals multiples of 3, full stop. List the elements of A, B, and C, full stop. B part of the question. Find A intersection B, Roman figure 2, A intersection C, Roman figure 3, B union C. We will solve the question now. Like I told you, every mathematical problem has a mathematical solution. So we will see the mathematical solution to the problem I just read out. Now, we were told in the question that the universal set is 1 to 20. So you have universal sets 1, 2, 3, 4, 5, up to 20. You can decide to list it out, but it's just a long list of numbers. Then they said A is multiples of 5. Now, multiples of 5 means numbers that are divisible by 5. So you have 5, you have 10, you have 15, you have 20. Those are the multiple of 5 that are in this universal set. Then B, multiples of 4. So you have 4, you have 8, you have 12, you have 16, you have 20. Then C, you have multiples of 3, 3, 6, 9, 12, 15, 18, So we have answered the first question that said, list the elements of A, B, and C. That is the first question, and you have been able to answer it. List the elements of A, B, and C. Then Roman figure 2 question now say we should find A intersection B. Now A intersection B means the elements that are common to A and B. Now let's look at the elements. Are there any elements common? Yes. 20 is here, 20 is here. So A intersection B will be 20. Another question says A intersection C. A intersection C. A intersection C means elements common to A and C. So what are the elements common? 15 is here, 15 is here. Any other one? No. So the intersection will be 15. Then the last question now say, find B union C. So you have B union C. B union C means leave the elements in B and C and don't repeat anyone. So you're going to have B union C to be 3, 4, 6, 8, 9, 12. Now you will see that 12 is here, 12 is here. It doesn't mean I'm going to write it twice. I'll still write it just one time. So 12, we have 15, we have 16, we have 18, and then we have 20. So this is what B union C. That answered our question number 2. It says, list the elements of A, B, and C, then find A intersection B, A intersection C, and B union C. So this is the solution to the second question. The third question for the day reads, the set A equals 1 to 11, B 2, 3, 5, 7, 11, 15, C 3, 6, 9, 12, 15 are subsets of universal sets 1 to 15. I'll come again. The set A equals 1 to 1, 3, 5, 7, 9, 11. Then B 2, 3, 5, 7, 11, and 15. And C 3, 6, 9, 12, 15 are subsets of universal set 1 to 15. The first question, draw a Venn diagram to illustrate the given information. Then the B part of the question, use your diagram to find A intersection, C intersection A complement. That's Roman figure 1. Then Roman figure 2 says A complement intersection B union C. Let's solve the question together. Let's solve the question together. Now, in this question, we were told that universal set is 1 to 15. The universal set is 1, 2, 3, 4, 5, 6, up to 15, depending on what you want. Then they told us that A, they gave us the elements in A. The elements in A are 1, 3, 5, 7, and then 9. Sorry, there is 11 there. 9 and 11. Then the elements in B are, the elements in B, 2, 3, 5, 7, 11, and then 15. Then the elements in C, they told us the elements in C, 3, 6, 9, 12, and then 15. These are the information given. The first question now says we should draw this, we should present this in a Venn diagram. So we look at this question, you're going to have a Venn diagram. You're going to have a Venn diagram. Now, you look at the question. Do we have elements common to the 3 of them? We don't. We don't have any element common to the three of them. But we have elements common to A and B. We have element common to the three of them. So you have A, you have B, and then you have C. Look at this. 3 is here, 3 is here, 3 is here. So you put it here. 3 is common to the three subsets. Then, if you look at A and B, there is 5, 5, 7, 7, 11, 11. So A and B, 5, 7, 11. Then, if you look at A and C, there is 3, 5, no, okay, there is 9, so you have 9. If you look at B and C, there is 15, Which other one? Nothing. So this place, 15. So if you go back to A, you have 1, 3, 5, 7, 9, 11. So you have already presented 11, 9, 7, 5, 3. So what is left is what? 1. You go for B, you have already presented 15, 11, 7, 5. You have presented 3. So what is left is 2. If you go for C, you have presented 9, you have presented 15, you have presented 3. So what is left is 6 and then 12. So you now look at the question. The universal set is 1 to 15. So we have 1, we have 2, we have 3. We don't have 4, so it will be here. We have 4, 5, we have 6, we have 7, we don't have 8. So 8 will be here. 7, 8, 9. Then we don't have 10. 10 will be here. 10 will be there. 10, 11, 12, 13 will be here. Then 14 will be here. So we have presented this information on the Venn diagram. Now note 4, 8, 13, 10, and 14. They are in the universal set, but they are not in the subset A, B, and C. Now the next question now says, we should find C intersection A complement. This is a question for us to do. And another question now says we should find A complement intersection B union C. This is another question for us. So how do we tackle this question? I'll pick the first one. We want to look for C intersection A complement. This is our question. So the first thing we need to do is to list the elements of A complement. Now, A complement are those elements that are in the universal set but are not in A. So it means we have 2, we have 4, we have 6, we have 8, we have 10, we have 12, we have 13, we have 14, we have 15. If you look at the list of these elements, they are not in A, but they are in the universal set. So they become A complement. Now, the intersection between this and C will be the answer to the question. So we have C intersection A complement becomes, what is common between this and this now? We have 15, we have 12, that is all. So you have 12 and you have 15. That is the answer to what? C intersection A complement. Now, another question says we should find A intersection B union C. For us to solve this question, it means we have to look for B union C. How do we get B union C? We get B union C by listing the elements in B and C without repeating any element. So we're going to have B union C, 2. 3 is here, 3 is here, so 3. We have 5. We have 6. We have 7. We have 9. We have 11. We have 12. We have 15. So this is B union C, the elements in B and C without repeating any. So if you go back to the original question, which is A intersection B union C, it now means the element common between this list of elements and this list of elements. So what are common? 2 is here, 2 is here. 6 is here, 6 is here. 12 is here, 12 is here. 15 is here, 15 is here. So you come here and list them out. So you have 2, you have 6, you have 12, and then you have 15. So that answers the question. So in my class today, I've been able to show you the application of what we did in our 2 previous classes on the terms that are used in sets. So I've been able to show you a practical knowledge of it, as in solving past questions. So we see how we can list out the elements, the intersection, the complement, and how we can even present them on a Venn diagram. So this note, I would like to call it off for today, but we'll still pick this same topic in my next video. See you. God bless.